Let's go MSY. MSY, why? First, look at the blue curve. From the blue dot to the red dot. This is what happened in the sea when the number of boats, the number of net, the number of hooks, or what we call the fishing effort, increases. When nobody goes fishing, the sea, the ecosystem, accepts a certain quantity of fish. That's what we call the ecosystem carrying capacity. This is the blue dot. This is the maximum biomass to ever see in the sea of one species. But be careful. This is not a very stable, permanent thing. This biomass can vary depending on the species, depending on the environmental condition. But this is, in a sense, what the sea, what the marine ecosystem can offer, can supply. More fishing boats go at sea, more nets are deployed, more hooks in the sea, and less is the biomass. Because aquatic resources or marine living resources are self-renewed. They are what we call renewable resources. But they are limited by the carrying capacity. And more you take, less they are parents, less they have time to reproduce. So more and quicker you take the fish, the adult fish if possible only, and less you have new fish coming in the stock or new recruits. So, more you fish, less there is fish in the sea. Now have a look at the red curve. What does the red curve tell us? If you are 5, 10 fishing boats in the sea, with plenty of fish in the sea, your production is not going to be much, but each fisherman is going to catch a lot of what he can catch. More fishers go to the sea, more production. But there is a limit to that increase. The limit is the limit of the capacity of the stock of fishes to reproduce. And this production curve passes a maximum. This is the well-known MSY. MSY stands for maximum sustainable yield. It is the maximum quantity that you can fish every year and that will be replenished by the nature without doing much of effort on our side. But if you go beyond, things start to become bad. Fish has no time to reproduce. Fish has no time enough to grow. And more boats, more fishers, but less production globally. And not only less production globally, less production for each boat with more expenses, more boats, so less and less profitability. And if you go down and down, or up and up in fishing effort, and down in biomass, then the production decreases. In some cases, you may reach a level of abundance of the fish that is called a critical stock. That is not always, but it has happened to some species, to some stocks. This is the red dot. This is the time where the species, the stock, just disappears. This is what we call species extinction. And species extinction can happen to a species of commercial interest, a target species for the fishing, but it can also happen to a protected species, a species that has no commercial value, but that because of bycatch by fishing boats or because of pollution of the sea reaches a critical level of biomass. What we have next and last on the graph is that if your fishing effort is beyond the level that produces the maximum sustainable yield, the MSY, we say that the fisheries is overexploited. So the issue here is just fishing regulation or fishing management. If regulation is loose, then we have a race for fish. As long as there is profit, there will be investment in new fishing boat. The fishing effort increases, the collective and also the individual performance decreases, and we come into overexploitation situation. To be noticed here is that overexploitation is sustainable. You can have very low biomass, very low productivity of the fishing gear and the fishing boat, but still, even if it's little profit, you can have for a long time very bad overexploited fishery that is sustainable. So that's the reason why talking about sustainability in fisheries is not just talking about capacity of the fishing enterprise to survive, but it is about stopping them to grow to the level where MSY is reached. And this is the reason why today all international agreements, policies, including the European Union Common Fisheries Policy, have set the maximum sustainable yield, the MSY, as the key target, the key objective for sustainability in fisheries. So that takes us up to fisheries management. How do we manage fisheries? We can manage fisheries in different ways. Remember that we want to have a limited fishing effort that produces the maximal sustainable yield. So we can limit the level of production. We call it a capture restriction. So as you go up in production, you stop when you reach the maximum sustainable yield, and is set in terms of total allowable catches. You can also decide to limit the number of boats, the number of nets, the number of hooks, the size of a mesh, and this goes into different groups. One is called the fishing effort restriction, where you distribute a limited number of fishing licenses, or technical measures that apply to the mesh size, the net length, the power of the engine of the boat, depending on how the effort is measured and controllable. But if you want to limit the number of boats or to control the level of catches, you have to allocate these rights to fish to the fishers. There are two main approaches to that. One is that it is the administration or a management body that distribute the licenses or the quotas to the total allowable catch. Or another approach, which is called a market-based instrument, well-known individual transferable quotas or ITQs, where fishers are own individual quotas and are free to trade them among themselves or outside. But maintaining the effort and biomass to the MSY level is not the only sustainability issue in fisheries. There are many others. Sometimes it's very difficult for fishers to be very targeted or very selective in the species they catch. So, by accident, they have bycatches. These bycatches might be species for which they have no rights, might be protected species, might be mammals, or others. Fisheries also contribute to a major environmental issue in the marine environment, the marine litter. And among the different marine litter, the ghost nets, or the nets that are lost at sea and continue fishing, is a major problem. Some gears, like bottom towed gears, bottom trawl, dredge, have an impact also on the sea, on the ecosystems. So all these create impacts, disturbances on biodiversity, on the trophic network, and also on the benthic habitats. But as we have seen first, seafood is not only capture fish, it is also aquaculture. And aquaculture has its own sustainability problems. We have many different types of aquaculture. Although the number of species that are produced in large volumes is quite limited. We have shellfishes with mainly mussels and oysters. We have the finch-fish culture. Fish-fin culture. In the marine finch-fish culture in the EU, well-known species are the salmon in the north, sea bass and sea bream in the south. But worldwide finfish culture supplies a large share of the European market. Known under different commercial name, tilapia species is a major one. We have also freshwaters. We have trout, we have carps, and catfish, and many others. And then another one, the shrimp farming. Shrimp farming occurs mainly in tropical waters, tropical coasts, and most of the shrimp that we eat in Europe comes from farming from tropical countries. So all these have more or less direct and indirect impacts. Some, like most of shellfish culture, are extensive. They do not require food, feed, or energy inputs. But still, they clearly have an impact on the benthic ecosystems and on biodiversity where they developed in the shore, on the shore, or offshore. With fish culture and shrimp farming, a lot of issues are open for discussion. Shrimp farming has been developed along the coast of tropical countries at the cost of cutting a lot of the mangrove areas that use to provide shelter, nursery for marine species, food, fuel to coastal populations. Intensification of this culture has gone with the use of a lot of feed, and sometimes antibiotics, chemicals that contributes to water pollution. Shrimp farming, finfish farming requires feed, and in the feed, protein. And to provide this protein, special fisheries, which are supplying the fish oil and meal industry, fishes, what we say down the food webs, a lot of small fishes that used to be food or fodder for larger species with higher value. So there is a trade-off between feeding aquaculture fish or shrimp or leaving that fish in the sea. With seafood international trade, and particularly the case of aquaculture shrimp, for example, large, long international route to supply northern rich countries goes with carbon footprint and all the impacts on global change processes that goes with that kind of trade. All these are sustainability issues that we should consider with thinking about the future of fisheries and aquaculture. So we have the pressures, we have the impacts. Let's talk about current responses in practice. As we said, for capture fisheries, fisheries management is a major area of concern and of development of regulation, of issues of difficulty to enforce this regulation, on engagement of all stakeholders so that they contribute to the development of the management and apply the rules that have been decided. Here is an example of the fishing total allowable catches and quotas set by the European Union for the year 2015. Another response is the development of marine protected area. Conservation policies now on land has quite some historical background. But setting marine protected area is quite a new thing. Within the European Union, the Natura 2000 network at sea is rapidly expanding. Marine reserve, natural park, fisheries reserve, all go with designing areas, engaging stakeholders in designing objectives, program of actions, so to reach collectively set conservation targets. To fully take account all the impacts of fishing, we now tend to apply a more ecosystemic approach to management. The ecosystemic approach to management looks on the impact on habitats, looks on the impacts on the trophic chain, includes the relation between birds and fish, includes impacts on protected species and the mammals. We can also think in terms of being more selective or more targeted for fisheries. And another way to reduce pressure on the marine ecosystems is to focus more on adding value to the fish caught than on catching more fish. And work is done to make value out of the skins, the bones, the fins, and all what we call co-products. Added value can be obtained through processing for higher value products, and also in rapidly growing biotechnology industries. So, the fish you buy today, how you will know it has been sustainably caught or sustainability farmed? Sustainability and traceability is the responsibility of all actors along the value chain. A fish, first, is one species. Is that species in a good biological status? Is it fished at the MSY level or below? It is also a type of vessel. It can be a small-scale artisanal fishery or a large industrial fishery. It can be available only at some season, because in other season the fishing is closed and you shouldn't eat that fish. The same fish or the same species can be caught by different fishing technique, more or less soft or hard on the ecosystem. The boat can belong to a country that is strict or not in applying fisheries regulation. This is the flag of the boat. And then it can come from any fishing area in the world. So how do you know that? How do we get information? Us consumers are often lost in the jungle of labels. Dozens and more every day of labels appear on the market. And they are not all the same. They do not all provide the same type of information. Appraising the quality of a label, the first question is the label a certification or only marketing? 3 questions we may ask. What are the specifications? What are the guidelines that supports your label? Is it transparent or non-transparent? If you can't find on internet what the labels provides as information, what it guarantees, it's a non-transparent label, and it's more likely to be only a private voluntary scheme for marketing, no more. So you should look for transparent, clear label. And you should know that no label can guarantee that the fish is caught or farmed environmentally and socially in all dimensions in a sustainable way. So, depending on what you want to eat as fish, you should look for the label that fits your requirements. In the labels, there are 2 families. Some are labels that are controlled, that we say are certified. Certification is given by independent third parties. The well-known label is the MSC, the Marine Stewardship Council label, which provides third-party certification, but which doesn't guarantee all environmental and social best condition of production. It has its own specifications. Other labels that are just self-produced by distributor or self-created don't have a third-party certification and may or may not have transparent information on what they guarantee. And even looking at third-party certification, we should be careful that it can be dependent from the company that used the label, and we should rather prefer independent label. Finally, campaigns run by NGOs or by research institutions, by European programs, aim at raising our awareness about problems, about issues, about how to go through the jungle of labels. This is a major response to which ocean literacy is a contribution.